Lesson 2, and now we're up to part 2. Let's talk about limits, function values, and continuity, but let's begin by looking at limits and function values. As you can see in this graph, we have a hole, we have an asymptote, and then we have a jump discontinuity. So I'm going to highlight each of those. We have a hole in the graph here. We have an asymptote here. And we have what is called a jump discontinuity, where there's a hole and the function literally picks up and finds itself continuing down here. So again, we have a hole, an asymptote, and then another hole with a point, which is called a jump discontinuity. But let's talk more importantly about the actual values here. So the limit as x approaches -1 of this function. So we're getting closer and closer to -1, which means we're going to trace it from this direction and then from this direction. And when we do that, that hole looks like it's approximately between 3 and 4 as a height. So we're going to say about 3.5. So that limit as x approaches -1 of the function is 3.5. But is there a value when x equals -1? I do not see a value. It's just a hole, and there's not a point anywhere else at -1. So we would say that f of -1 is undefined. So in this scenario, the limit is not equal to the function value. Let's try the limit as x approaches 2. Take a look as we get closer and closer to 2. This limit is clearly heading towards -infinity. And if we approach it from the other direction, it is approaching positive infinity. So that limit not only does not exist, but it's going into completely opposite directions. So we would say this limit does not exist. Now, do you see a point value anywhere at x equals 2? Again, the answer is no. So we would have to say that f of 2 is undefined. And we can say that the limit is not equal to the function value. Let's try the limit as x goes to 5. So here, we're approaching x equals 5. And as we get closer and closer, we get to about the height right here. And from this direction, we get closer and closer to a height down here. So from the left side, our limit looks like it's approaching the y value of 1. And from our right side, it looks like it is approaching, a value of -1. So the limit from the left does not equal the limit from the right. So again, the limit does not exist. But more clearly, let's look at what happens at f of 5. The function value at 5 certainly does exist. There's a point there. So the limit does not exist, but the function value does, and the value of f of 5 is actually -1.